Hello guys, this is EDU-SOLUTION. This is what we do, providing answers to every of your questions. So I want to use this moment to tell you that if you have not subscribed to our channel, why wasting time? So go ahead and do that, just subscribe and also turn on the notification bell so that you'll be one of the first who receives content as soon as it drops. And also before now, we have done a few videos on a few topics in mathematics and also in physics. So also do well to go through our channel so that you also gain access to all of it. So based on request again today, we want to take a topic which is indices. Okay, and this is a very simple and it's not something that is difficult. So, but I don't know why a few students have issue with this, especially when it gets to the advanced part of it. So these are what we are going to do today. So as it relates to indices, when we talk about indices, it has to do more with exponent or power. So that you have a number like an integer having a power. So if we are having something like that, that's when we relate it to indices. So indices is the plural form. The singular is index. Okay. So before we'll be able to solve or do anything under this work, we need to apply the rules. That's what we call the rules of indices. So let me begin with that, which is the rules of, you can call it rules or you can call it laws. So we have laws or rules of indices. Okay, I will just begin by outlining them. Let's take the first one. We have, meanwhile, there is no number that this one that I want to write as number one must be number one. No. So, and we have, let's say we have a variable y raised to the power of a times another variable raised to the power of b. We have something like this. The rule says that we'll pick one of them, we'll have y raised to the power a plus b. Okay, and if you want to compare this with another thing, if you have y raised to the power a times s raised to the power of b, please, it is not equal to x raised to the power of a plus b, or y is not also equal to y raised to the power of a plus b. So this is wrong. So the reason being that we are having, it must be the same variable y and y before we can have this to be correct. So this is not correct because this is y, this is x. So we cannot have it this way, we cannot have it this way. So that's number one. Number two, we are having, I'm using y throughout, so it can be other variables. So we have y raised to the power of a divided by y raised to the power of b. So that you write it in this form, or you can find it also in this form, that y raised to the power of a over y raised to the power of b. So this is equal to, since they are of the same variable, we pick one, and then we have the power of the numerator minus the power of the denominator. That's number two. Number three, let me call this the zero power law. We have y raised to the power of 0. Anything raised to the power of 0 is what? 1. Okay, I hope you are following. So that is that. Number four, if we have also, like I said, I'm using y throughout, y raised to the power of minus a. This in indices, minus here means 1 over, so that means we are having 1 over y raised to the power of a. Okay, and then let's say under this same concept, I want to bring your mind to this, because when we begin to solve properly, then I will always refer you to what I want to do now. If we have also that y over x, everything raised to the power of minus 1. If we have something like this, this is what it's going to give to you. It's going to give you, just like an inversion, we are inverting, it's going to give you x over y. So that is going to be the result. So this minus here, as in the case of this, minus means 1 over. So we're having 1 over, and then we have y over x. So we have y over x, both of them raised to the power of 1. So this minus is 1 over, and then y over x, which is now equal to raised to the power 1, sorry. So now anything raised to the power 1 is the same thing. So I can have it as 1 instead of this over, I'll use divide by, and then have y over x. So that according to BODMAS, we have 1 divided by 1. This divide becomes multiplication, and then we invert this according to BODMAS, we're having this. So this multiply this, we are having x, and this multiply this, we are having y. So x over y. This is the reason why this is equal to x over y. And also number 5, I think, let me clean this part. So also have before number 5, there's another one relating to this. So that we have 1 over x, everything raised to the power of minus a. So what I have done here, you are going to do that by yourself. You will find out that this expression is equal to s raised to the power of a. So you do that by yourself, and then you will find that this is equal to this. Okay, and then number 5, let's say we are having y raised to the power of 1 over a. Okay, if we're having something like this, the power is fraction. The denominator of the power is going to take the root of this y. So that means the denominator here is what? A. So we are having now the a root of y, everything raised to the power of the numerator of the power, which is 1. Anything raised to the power 1 is the same thing. So I can put it, I may leave it, so it's not necessary. And then we have, I think, okay, second to the last, we have y raised to the power of b over a. So if we have something like this, just same as this, we are going to be having the denominator of the power, which is a. So we have a root of y, and then everything raised to the power of the numerator of the power, which is b. So in the same way, number 7, if we have y raised to the power of minus b over a, so you can see the power here is also fraction, but it's having minus. So if we also relate it to what we have here, the minus here means 1 over, and then this now becomes the expression that we are putting here now. So we're now having a root of, okay, let me write it this way first. Minus here means 1 over, and then b over a. So have b over a, which is same as 1 over. You can see this expression, the denominator here is not similar to this. So I can put this now, put it here. So if you understand this, so the same thing I'm doing here. So I have a root of y, everything raised to the power of b. So and finally, under the laws or rules of indices, if there's another one, I will let you know. So we have y raised to the power of a, everything in bracket raised to the power of b. So whenever we have a term having its own power multiplied by another power, so like bracket like this, what we do is to pick this one, and then we have a times, so the power here multiplied by the power here. So we're having a times b. So a times b is what? ab. So let's stop here. These are the laws of indices. So you take your time to go through all of these laws, and then when we now begin to solve questions, it will be very easy for us. So I think let's take some basic questions. So let's take some basic questions. This is a question. So let's find out the solution to this. So this is a very basic question. So anyway, we can find this as an OBJ question in WIAC, any external exam. So we're having something like this. So I think the first thing we're going to do is to consider the things that are inside. We'll have 8 squared, and then we'll have 4 raised to the power of n plus 1, and then we'll have 2 raised to the power of 2n, and then we'll have 16. So I always advise in situations like this, it is very important that we have to consider the terms and also the power. Okay. Now, if you check the terms, the numerator here, this is 8 squared, this is 4 raised to the power of n plus 1. I want us to relate this to the expression in number 1. The laws of indices, the first one, we have y and another y. So since they are the same thing, we took one of them, and then we have to add the power. So this is same thing that we're having here. So you can see that there's an addition here. So that means if we want to simplify this, it's not going to be in this form. So we are going to be having 8 squared times 4 raised to the power of n times 4 raised to the power of so this 4 raised to the power n is for the first one, and then times 4 raised to the power of 1, because this is 4, this is 4. So if we pick one of them, that we add the power, we will return back to this expression again. So that we are having now 2 raised to the power of 2n times this is 16. Is there anything we can raise to the power of 2 raised to the power of something to give us 16? So that is 2 raised to the power of 4, right? So 2 raised to the power of 4 is going to give us 16. So now we will continue from there. There are different approaches you can apply here. So now we have 8 squared. I want to rewrite again. This 8 squared, I can write it as 2 raised to the power of 3, which is 2 raised to the power of 3 is 8, and then we have this, and then we have times 4 raised to the power of n times, this is 4, we can have 2 raised to the power of 2 to give us 4. If I like, I can put this one here, and then I have 2 raised to the power of 2n times 2 raised to the power of 4. So this is where, okay, I think I can also change this. Let me change this also. We have 2 raised to the power of 2, and then we have our n. So this is 4, 2 raised to the power of 2, and then we have our n. And I think on the final note, so we have 2 raised to the power of 3 times 2 is, like I told you, the last law I gave you here. This is it. Number 8, so that we have power here, another power, we have to multiply them. So we're having 3 times 2 is what? 6, and then times, this is 2 times n is 2 raised to the power of 2n, and then times 2 times 1, we have 2 raised to the power of 2, everything over 2 raised to the power of 2n. Meanwhile, this is covering all of them. So 2 raised to the power of 2n times 2 raised to the power of 4. So this 2 raised to the power of 2n here is going to cancel this one. So that what we are having left is, we are having this left. So we have 2 raised to the power of 6 times 2 raised to the power of, 2 raised to the power of 2, everything over 2 raised to the power of 4. So if we check this out, you will see that this is 2, this is 2. We pick one of them, which is now 2, and then we'll add the power. Since it's times, so we'll add the power. 6 plus 2 is 8, and then over 2 raised to the power of 4. So just also in the same way, this is 2, this is 2. So we'll also pick one of them, and then we'll subtract the power because it's a division. 8 minus 4 is going to give us 4. So that I cannot have it as I can write it also as square root of 2 raised to the power of 2, and then 2, because look at this. This 2 is what we have here, and 2 times 2 is 4. So the reason why I'm doing it this way, so that I can easily cancel out. So this square root now is going to cancel this one. So what we have left is just 2 raised to the power of 2, which is equal to what? 4. So that's beautiful. I hope we get that.